Now our denominator is a monomial. A monomial meaning it doesn't have a plus or minus sign. If it doesn't have a plus or minus sign, are those two numbers, is the number and the variable connected? Stuck together for life? No. So we put them in their own brackets. So we simplify our denominator if we can. We can't. It's a monomial. There's nothing you can simplify. However, we're now going to try and make common denominators. Both the denominators have what in common already? The p. So do we have to multiply them each by a p to make it common? No, the p's are already common. The only thing that's not common is the 3 and the 7, so we have to make that common. What's common to 3 and 7? 21. So we're going to multiply this one by 7 and this one by 7, and we're going to multiply this one by 3 and this one by 3. And because they're monomials, we'll distribute it in. So we get 35 on the top numerator over 21p plus 6 over 21p. What can we do now? We can combine them because we got, right. So we get 35 plus 6 over 21p, which is actually 41 over 21p. If I could simplify in the very last step, I could. But I always have to state non-permissible values before I do what? Cancel. Before you simplify, you have to state your non-permissible values. There is nothing we can simplify, so it's going to stay this way. What would our MPV be? P cannot equal 0, because in the denominator we have 21 by itself and p by itself. 21 can't be 0, and if you have a p or a p squared or p cubed or p4, those are all p cannot equal 0 for NPVs, right? And we're done. This is our answer. Okay? We're going to look at B now. In this entire example, we're simplifying. It's going to say simplify, but we know we have to add and subtract because that's the symbols between the two rationals. Some people are like looking for adding and subtracting. It's not going to say add and subtract. It's going to say simplify, and you're going to look at it, and you're going to say, oh, there's a plus sign. I must add these, okay? So if I have to add them, I need a common denominator. So I have a 3 and a y and a 5. Anything common to any of that? No. The right-hand side has a y in the denominator. My right-hand side. Your left-hand side has a y in the denominator. Yes? So the right-hand side needs a y. So I have 1 over 3y plus 6 over 5. So I know at the very least I'm going to have to multiply this side by y. So now they have a y in common, correct? But are they common denominators? No. One is a 3y now, and the other one is a 5y. So what do I have to multiply them also by? The right or the left-hand side by what? 5, and the right-hand side by, so that I get a common denominator of 15y. So I'm going to multiply by 5 over here and 3 over here. And this is equal to this expression is equal to 5 over 15y plus 18y over 15y. Now we have a common denominator, so you can write them over each other. 5 plus 18y all over 15y. The 5 plus 18y is connected, is it not? So I'm going to put brackets around it so I don't accidentally try and cross off the 5 and the 15, because I can't, right? 5 plus 18y is only going away if there's a 5 plus 18y in the denominator. Is there? No, so this can't simplify anymore. Okay? And what would my non-permissible value be? Y can't equal 0. Now, you should put that as it. If on the diploma they don't have brackets around the 5 plus 18y and they don't have brackets around the 15 and the y, is that a problem? No, it's the exact same thing, right? The only reason why I told you to put brackets around them is to try and get you to not cancel off too many things, because people oversimplify. Rarely do they undersimplify. Okay, I want you to try C and D, and then we're going to go through them. Do them quickly, please, quickly. So this denominator is 6 and an x. This denominator has 3 and an x. we have 2x minus 5 over 6 times x. What do they share in common right now? An x. The only thing is the right-hand side needs a 2, correct? So we're going to get 2x minus 5 over 6x minus 6x minus 4 all over 6x. And then we have the minus sign in between, right? So what do we have to remember to do with the minus sign, guys? It has to apply to everything behind it. So you're going to get 6x in the denominator. In the numerator, you're going to get 2x minus 5, and you're minusing that whole bracket, right? So you're going to get minus 6x plus 4. If you forget to apply it to the 4, they will have the answer there if you forget to, right? And then we get 2x minus 6x, which is negative 4x, minus 5 plus 4 minus 1 over 6 and x. And because we have an x in the denominator, this whole thing is in its own brackets because it's attached to a minus sign. Our NPVs are going to be x cannot equal 0. D, we have a plus 7 over 2a squared. And 2a squared is just an a and an a, technically, correct? We're not going to write it like that after. I'm just proving a point. And then 3, and then a 5, and an a. So what's missing from the left-hand side? A 5. Remember, we can't divide to make common denominators. We can only multiply. Okay? This one has 1a, this one has 1a, but this one has another a, does it not? So this one needs another a, and it needs a 2. So on the top here, I have to put my 5 through. I get 5a plus 35 over 10a squared minus 6a over 10a squared. And now I have a common denominator. So 5a plus 35 minus 6a over 10a squared. 5a minus 6a negative a plus 35 in brackets all over 10 a squared. When I have an a squared, what's my MPV? A cannot equal 0. If I have an a cubed, a squared, a4, a5. It's just two a's separately, right? Okay. And the next page. All right, so now we're not going to just have monomials in the denominator. We might have a monomial and a binomial. We might have two binomials that are different, anything like that. Okay? So my concern for you is, in order to make common denominators, always take your denominators and simplify them and bracket them if possible. So wherever you put brackets, put brackets. If you can take a GCF out of one of the denominators to make them be the same, do that. Okay? But brackets are very important. So in this denominator, I have x minus 9 over 2 times x. And I can put them in separate brackets because they are what? They're separate because they are multiplied, right? They're not connected by plus or minus signs. They're separate entities. Then I have plus 3x, and I have x minus 4. We agree? What am I doing to the top and the bottom to get common denominators? What operation do I always do to make common denominators? Multiplication. So I'm not allowed to divide. I'm not allowed to add something onto it, right? It's multiply. Okay? So I have 2, and I have x, and I have x minus 4. What was the only way I could cancel an x minus 4 off the top? If there was x minus 4 in the denominator, right? So if you have an x minus 4 in the denominator, the only way you're getting an x minus 4 in the other denominator is multiplying by it. That's it. You can't take that x and subtract 4 because you can't just subtract tops and bottoms. To make common denominators, you must multiply. And if I multiply an x by -4, do I have x minus 4? No, and x times -4 is -4x. It's not the same thing. Okay? So actually, when I have a binomial, unless I can take a GCF out of the other one and then they're the same binomial, you actually have to multiply them by it. That's it. That's the only way you can deal with it. So my right-hand side has an x minus 4. My left-hand side does not. So I need to make it have one. So I put the equal sign out here, actually, and I'm going to multiply this by x minus 4. When I do the top, I have to do the bottom. So I know if I have a binomial and the other side does not, the only way I'm going to get that binomial over there is to put it over there. Now the left-hand side is 2 and x. The right-hand side has no 2 and it has no x. So what am I going to have to multiply it by? 2x. To be honest, most people are not great at these ones, but these ones are way easier than the other ones. There's usually nothing in common. You multiply them by each other. Really? It takes the guessing work out, but people suck at them. So I don't know why. I feel like it's just because it's a binomial and you think there's got to be an easier way. Like there's got to be prettier. I mustn't have to FOIL, but you do. Sorry. Maybe that's why. So then we put a 2x and a 2x, right? Okay. Now, I'm not going to do this in one step, and I would not suggest you as well do this in one step, okay? I would rewrite this and then FOIL it, because right now sometimes people mess up and like they just don't get it correct. So on the top left, I'm going to have x minus 4 times x minus 9. And then in the bottom, I'm going to have 2x times x minus 4. I never distribute the bottoms. I never distribute the denominators. Why would I not distribute the denominators? What have I not stated? MPVs. If I distribute them back in, what am I going to have to do? GCF them back out to state MPVs. Would that be productive? No. So you never distribute the denominators. You always distribute the numerators, but never the denominators. Okay? Unless it's a monomial. When it was a monomial, we put it together as like 35x, right? That was fine. But if there's a binomial in the denominator at all, you just leave them separate because then your MPVs are way easier. Plus, if you put them together, they're not simplified. Okay, then we have plus 3x times 2x. 2x times x minus 4. Okay, let's distribute the tops. This is FOILing. Remember, first, outer, inner, last, binomial times binomial? So you have to do the first terms together first. I'm going to use a different color. Okay. So we do x times x, which is x squared, x times -9, so the outside terms, -9x. Then the inside terms, -4 times x, -4x. And then the last terms, -4 times -9, positive 36 over 2x, x minus 4. Plus this side's easier, 3x times 2x. 6x squared. It's not FOILing. Why is it not FOILing? Why do I not have to go first, outer, inner, last? There's no addition or subtraction. This is one term, right? So no first, outer, inner, last. So it's just 3x times 2x, which is 6x squared, over 2x, x minus 4. So then we're going to get x squared minus 9x minus 4x plus 36 plus 6x squared. No. All over 2x times x minus 4. And then we collect like terms. 6x squared plus x squared, 7x squared. Negative 9x minus 4x, negative 13x, and then just plus 36. 2x, x minus 4. And my non-permissible values are x cannot equal 0 and 4. That's it. I want you to try G. Try G. And F, sorry. G and F. Try F first, it's easier. By the way, there's nothing in common. You have to multiply each denominator by each other, right? There's nothing in common. They're both binomials. No GCFs out. Okay. So here we're going to multiply 4 over 2y plus 5. We're going to multiply the top and the bottom by y minus 3. Numerator in the denominator. Minus 1 over y minus 3. I'm going to multiply by the other one, 2y plus 5. Now, do I FOIL the denominators? No, if you FOIL them, you can't get your MPVs, right? So don't. So I'm going to distribute the 4 in. So I get 4y minus 12 over y minus 3, 2y plus 5, minus 2y plus 5 over 2y plus 5, y minus 3. I just do it one step. Yeah, it will be. So then we're getting 4y minus 12 minus 2y minus 5, because you have to subtract both, over 2y plus 5y minus 3. Collect like terms. 4y minus 2y is 2y. Negative 12 minus 5, negative 17, which I can't GCF or do anything to that. 2y plus 5, y minus 3. Your non-permissible value for 2y plus 5 cannot equal 0. Subtract 5. 2y cannot equal negative 5. Divide by 2. Y cannot equal negative 5 halves. And 3. Now that question is easier than G, because G, you're going to have to FOIL the numerators. So this one I have 2x plus 1 over x minus 5. There's nothing I can do to the x minus 5. It stays that way. Minus x minus 4 times x plus 1. There's nothing I can do to the x plus 1. I can't FOIL it or factor it or anything, right? It's as good as it gets. So I have to multiply both sides by that, by each of the denominators, to make them common. So x plus 1, x plus 1, x minus 5, x minus 5. In the top I get 2x squared times x, or plus x. 1 times 2x plus 2x. 1 times 1 plus 1 over x plus 1, x minus 5. Minus x times x, which is x squared. X times negative 4, which is negative 4x. Negative 5 times x is negative 5x. Negative 5 times negative 4 is positive 20. Write all of the denominator x plus 1, x minus 5. And we get 2x squared plus x plus 2x plus 1 minus all of these. So it's going to change the sign of every single term, right? minus x squared plus 4x plus 5x minus 20. And then we're going to collect like terms. 2x squared minus x squared, 1x squared. X plus 2x is 3x. 4x plus 5x is 9x. Let's go plus 12x. Positive 1 minus 20, negative 19, all over x plus 1, x minus 5. X cannot equal negative 1 or 5. Okay? So we're going to practice some of those. Then we get to harder ones. It's the last one, and then we're going to do adding and subtracting on Monday and start solving. Because look, what's up with these ones? H. This is the difference of squares, right? So you're not going to do this one today, but I'm just going to show you. You get 4 over, you get p plus 1, p minus 1 in brackets, right? Plus 2 over p plus 1. These are actually not as bad as they look. What do they both have in common right now? P plus 1. So I only have to multiply this left, or the right-hand side for you, by p minus 1, right? But the hardest part is figuring out how I can reduce them. That's what we're going to do on Monday. So your questions for today, though, are in the same questions from the same part of yesterday. So page 249 again. Number 5 is like today's, and then I'm giving you some review work too, so you remember it. How to do the rest. So number 5 is the adding and subtracting from today. There's 4 questions. And then page 265, 3CD, 4BC, 5CD, 6CD. 3 and 4 are simplifying just basic rational, something over something. And then 5 is multiplication and 6 is division. Because remember, your test is going to be next week. Because all we have left is just adding that little bit of adding and subtracting and solving. So make sure you can do all of this stuff, right? So get working.